Alright, question 4. First part is okay. The last part is quite challenging. And 4 gold, 6 silver, you're picking out of a bag and you're putting them back in with replacement. So we'll say probability gold 4/10, and probability silver 6/10. And I'm going to leave them unreduced. Part A says probability x equals 0, which is code, since we're describing x is the number of gold that you're drawing. And you say, well, no gold, that's the same as probability, say, silver. So in algebra 2 you probably wrote it like this, and now we're just assigning x to represent how many gold are drawn. And these are independent. We're just going to take this and 6/10 multiplied by itself, since we put the silver ball back in and it could potentially redraw it. So 6/10 times 6/10 is 36/100, or 36%. That's part I. I probability x equals 1. Alright, so that means we could get silver gold or gold silver. And probability silver gold or gold silver. And so now we'll do the same thing for each of these, but add them together. So this is 6/10 times 4/10 plus 4/10 times 6/10, which this would be 24/100 plus another 24/100, 48/100. Okay, part A, not so bad. Part B, now you're going to do this 14 times. So it says 14 balls are drawn, and you're like, well, there's only 10 in the bag, so how are we doing that? But it's one at a time, and you put them back is the implication. So 14 trials. Now that should tell us if we're only silver or gold, there's 2 options. It's either one or the other, and we're doing this a lot of times, 14 that is. Now we're moving from a tree diagram into a binomial probability. And part B says that that we get exactly 5. Probability x equals 5. And now it's too much trouble to write out. So if you're doing 14, it's impractical to write it out like I was doing for part A. So now we have to be a little bit more savvy about doing our binomial probabilities. 5 gold, which means that 9 silvers, and some, gold, in fact, 2, 3, 5. Okay, so the question is, how many ways can you scramble this up and still have 5 and 9? And the amount of ways, if you have 14 and you want to choose 5 to be the gold ones, and it doesn't matter if you pick 9 to be the silver, it's the same number, because if you recall, the Pascal's triangle is symmetrical whether you read it from left or right. So if you want to do 14, choose 5 gold, or if you want to do 14, choose 9 silver, it's the same number. Okay, then the 4/10, the gold, so 4/10 is probability gold, and we want 5 of those. 4/10 times 4/10 times 4/10 times 4/10 times 4/10 times 6/10, 6/10, and so on. So we got 6/10, 9 of those. And now we just have to calculate this value. And so this is a calculator question, because doing 14 factorial, that's too challenging without a calculator, too time consuming. Okay, so if we punch this in, it is 2002 combinations of 5 and 9 times 4/10 to the 5th. Well, I'll just write this again for now. Alright, so if we just go ahead and calculate that number, it's pretty close, 20.66%. All right. Now, at most 5, so far so good here. At most 5. Okay, part C, a little more complicated. At most 5 gold, that would be all of these scenarios. And we just figured out this one that I scrunched in here on the side of the page. Probability that we get 5 gold was 20.66. And let's do each of these individually now. Probability X is 1. That would be 14. X is 0 rather. 14, choose 0. They're all silver. 4, 6 to the 14th. Okay, so that one would be here. And if we crunch this number, this one is 0.0007. It's almost impossible to draw 14 silvers. Okay, probability X is 1 would be 14, choose 1. 14, that would be, this should have been 6/10. Got that wrong. Okay, sorry, 6/10 for silver, 4/10 for gold. So we want one of those, 13 of those. And that calculates out to 0.73%. Again, highly unlikely. Okay, that was this one. Let's do this one. X is 2. 14, choose 2. Uh, 3.17. Okay, possible but slim. And then X is 3. Okay, and lastly, all right, so we did each one of these and we add them all up. Probability X is less than or equal to 5. If we add each of these up, it's close, it's called 48.5%. If we round a little bit there on the numbers. Okay, there is a calculator way to do this, and the calculator requires us to do cumulative frequency, so we'll go to probability, or rather distribution, so distribution, and this is a binomial. Now PDF is if we just want to do one of these. Cumulative CDF is if we want to add a whole bunch of these together, and that's the one that we want. Now we're going to do 14 trials, and we want our probability. This is going to be 0.4 for gold, and the X value that we want is 5. Alright, so 48.5. Now, so if you were savvy enough with the calculator, you could avoid doing the individual calculations because the calculator is doing these for us. If you know where to look on the distribution, again, in distribution, second bars, and then all the way down and go up to get back to option B there. Okay, last question. So 48.5. Now you have probability, so this is D, probability that x is 5 given that x is less than or equal to 5. Alright, so it's like you know you drew fewer than 5 silver, gold. Probability that out of that total, which is 48.5%. So you're not picking from all of the possibilities, you're only picking from the possibilities that are 5 or less. Probability that you get exactly 5 is the 20.66%. So this is the numerator, and then this is the denominator, which makes 42.6% chance. And you can see, well, that's not too far off from 48 because it's highly unlikely that we're getting 0 or even 1 gold. It's more likely that we're getting, in fact, it's the most likely to get this one, if not the others.